The Internet, particularly the web, has become an integral part of nearly everyone's daily life. While the web offers numerous benefits that improve our lives, it also presents opportunities for cyber attackers to gain unauthorized access to our data and compromise systems for their own gains. This raises questions that many people might wonder about. How dangerous can the web really be? What is the highest level of a risk a hacker can pose? Can a hacker access my hard drive files through a compromised website? The list can go endlessly. But the key question is, what can we do to prevent these attacks and increase our security? In this video, we will answer these questions in a very simple and intuitive language, such that any web user can understand. Before diving any further into the answers, we have to distinguish different possibilities of the web cyber attack scenarios. The first scenario is when a hacker creates and operates a malicious website, perhaps with some attractive contents to lure people with the aim of attacking web users who visit and load the malicious website. The second scenario is related to the situation when a hacker exploits some security vulnerabilities from a legitimate and trusted website in order to pursue his/hers malicious intentions. This video focuses on the first scenario, security risks of malicious websites created by hackers and how to mitigate these risks. The second scenario would be the focus of the next video, which will come soon. Okay, we can get into the point. However, before diving into explanations, we will provide a brief overview of how web pages work for those without a strong technical understanding. A website is essentially a collection of web pages linked together. A web page is a document file executed by a browser, a program that allows users to view and interact with online content. Web pages are built using three main program languages: HTML, which structures the layout, design, and the static content; CSS, which defines the presentation and styling; and JavaScript, which is executed on the web user devices, enabling dynamic and interactive behaviors on the web page. Among these, JavaScript is particularly dangerous. It is because JavaScript, unlike the static HTML code, can be executed within the browser and gives lots of powers to the web page to run some code within the browser and for getting some dynamic pages, and also to receive input data from users on the web servers. This feature is what makes the website both powerful and dangerous at the same time, as it also allows attackers to send and execute malicious JavaScript code on user browser. Now, let's explore what a web page with malicious JavaScript code can do. Can a website with the malicious code access the data from other programs or the files stored on the hard disk? For example, if the browser is open and loads a malicious website and you are also using PowerPoint to create some slides, can the malicious web page access, alter, or even delete the PowerPoint file? The answer, in theory, is no, thanks to the isolation mechanism implemented into the operating systems. The isolation mechanism, which is also called sandboxing, allocates a specific portion of memory to each program and prevents accessing the memory of other programs. It means that if the browser wants to access the data of any other programs, such as the slides mentioned in the example, the operating system will block the access. Of course, unless you are tricked into granting them access through social engineering or fraudulent prompts. Now that we learned that the attacker cannot pose a threat to the programs outside of the browser environment, let's review the cyber threat within the browser environment. Suppose that you have one browser window or tab open to a website that is trusted by you, and it contains some sensitive information about you, such as Gmail, and another window running a malicious website. Can the malicious website access the data from the other browser, window, or tab? The answer to this question is also no. Of course, theoretically again, browsers implement a security mechanism called enforcing same origin policy, which restricts integration between scripts from different origins. But what is origin? An origin is defined by the combination of the following parameters: host, which is the URL root, communication protocol, and port number, which identifies the service that processes the web data both at the user and server side. For example, if you have two open browser tabs, the trusted site and the malicious site. The malicious site cannot access or interact with the data from the marketplace site because they have different origins. This prevents hackers from using one website to steal sensitive information from another. Okay, so based on the security measures explained, the malicious actor can only have the opportunity of deceiving users to download malware or receive some sensitive information from the user by adding a login page to steal the user password, for instance. This is of course already too much, because if a malware is executed at the user device, it could give access to lots of resources and information to the attacker. And basically, they don't ask the user, please download the malware, but they ask users to download a program with a claimed use case which has some attractions based on the user type. But next to the claimed app, it contains malware, which will be executed and run without the user being aware. This type of malware is called Trojan horse. Unfortunately, the isolation and the same origin policy that was mentioned before could also be bypassed in some situations. It means that in practice, it could be possible for the hacker to facilitate downloading of the malware even without any interactions from the user, and by simply loading the web page. This type of attack is called drive-in download and exploits some security weaknesses from the browsers and allows the malware download. Browsers, like any other IT products, could have some security weaknesses, which for example allows a code to execute a command with the browser. Some hackers could discover these vulnerabilities and create a web page that can exploit this vulnerability upon loading. For example, in December 2023, a vulnerability was discovered in Chrome, which enables compromise of the victim's device when they visit a malicious website. This weakness allowed an attacker to compromise and execute arbitrary code in Chrome, render, process, and download malware. Apart from the browser's vulnerabilities, some websites also could have a weakness that allows breaking the same origin policy enforcement. Any web page has a set of instructions, which are defined by the developers and states the configurations of the browsers in respect to their web page. These instructions are called the HTTP header and allows the developer to specify some specific sources that can interact with the data of the web page. However, in case the developers by mistake allow the browser to ignore same origin policy for any sources, the browser would then give access to any JavaScript code on any web page to access the data. A hacker could notice this vulnerability, create a website that runs malicious JavaScript code, and access the vulnerable website's data. A similar attack, which is called clickjacking, exploits a vulnerability in the HTTP headers of the web page and includes a frame of the vulnerable website into their malicious web page. When a user loads the malicious web page, the vulnerable and legitimate web page within the frame also will be loaded. And by loading this, the user data also will be there. For example, if the user has authenticated, the user profile also will be loaded in the frame. By this way, the hacker could have lots of opportunities to access user data from the legitimate website. Okay, we explained the situation. There are some strict security measures included in the operating systems, browsers, and the HTTP protocols. However, as they are created by human beings, there could always be security vulnerabilities with these products, and gives opportunities to the hackers to exploit them for their own gains. So what should we do as the innocent users? Our recommendation for the web users is neither to be too scared with the web cyber attacks, nor too reliant on the security measures. Surf the internet based on the requirements, but try to avoid any website that might be malicious as much as possible. For example, don't open suspicious emails. Additionally, try to always prioritize updating the operating system or browsers as soon as a new version is released. By this way, you can protect your systems from the security vulnerabilities for the browser or the operating system. And finally, use a password manager application to have a unique password for every application. By this way, even if the malicious actor can access your password, they cannot use it for other applications and websites. You can use password management systems such as the Google Password Manager, LastPass, KeePass, and the professional 1Password apps. Thanks for watching, and we hope you found it useful. Please stay tuned for the next video where we will explain the possibilities of hackers posing cyber threats via trusted websites.